Alright, so we're going to do a Chapter 3 review here. This entire chapter was about quadratics and parabolas, so we have to remember how to complete the square. Now, I'll give you a hint. If it says complete the square in the final and you use H and K, I'll never know. Okay, good to know. How do you complete the square? Step 1. Tino's got this written on his note card? Okay, so look at the two x's and get the x squared alone by factoring out a 3. X squared plus 2x. Now what do I do to that 4? Shove him way off to the side. Does he get factored by 3? No. Okay, so that constant, just shove him off to the side. Now it's time to take that new middle term. Take your b, half, and square makes plus 1. Is it always plus? Yes, because squaring makes plus. Okay, now is it really plus 1 or is it in disguise? Okay, so if that's plus 3 in disguise, let's go ahead and subtract 3. Okay, and now the fun part is the factoring. So we've got f of x equals 3, vertical stretch of 3. The quantity x plus 1 squared plus 1. So the vertex, -1, comma 1. This graph opens up. Line of symmetry. When you have a parabola opening up, there's always going to be a vertical line. That's a vux, a vertical line, at x equals, yeah, you just take the x number, -1. The transformations that this graph has, there's a 3 out in front. That vertical stretch. Vertical stretch by 3. 1 to the left, and 1 unit up. Okay, those are all the transformations, no reflections. So we go 1 to the left, 1 up. The graph opens up with a vertical stretch. So over 1 up, 3. Over 1 up. No? No? Okay, it's usually 1, 3, 5. But we're going to do 3, 9, 15. So I don't think 9 is going to fit. Okay. On the multiple choice final, if you know where to start and you know that the first box is over 1 up 3, you'll probably be able to find it. Okay, even if you mess up the second number. All right. Any questions on completing the square, graphing? Okay. Here's a really nice parabola question. This equation was for something special. Projectile motion. Okay, so projectile motion is when you throw something into the air, it comes back down. It's the shape of a parabola. The basic equation is -16t squared plus v naught t, initial velocity, plus h naught, initial height. Okay, and remember, for this equation, let's just remind people, units are and seconds. Okay, feet and seconds. So the initial height, this should take you about 1 second. Can you be more specific? 10 feet. Initial velocity. Feet per second. Oh, what if I put meters per second? I'll get some of you, right? Okay. H and K. So that's talking about the vertex of the parabola. So now we're going to have to remember those formulas. So that -b over 2a, and the k formula is c minus b squared over 4a. So let's go ahead and calculate the h. -b would be -36, 2a, -32. Cancel the negatives. Let's cancel by 4. Let's cancel here. We've got to simplify. Cancel by, oh, do you know 4 or do you want to do 2? 9 over 8. Okay, however you got to get there. So the h is 9 over 8. Seconds or feet? Oh, you know what really helps? It really helps when I draw the graph. We've got the t-axis and the h of t-axis. Does it start at the ground? No, it starts at 10. Parabola opening down, and we just found the h. We just found the x value. So now that I look at my graph, I realize that that goes with the time, so that must be seconds. All right, I just scribbled all over my k area. I'll have to do k over here. C is 10 minus b squared. Let's just write 36 times 36 all over 4a. Cancel the negatives. Let's cancel by 4. What's 36 divided by 4? Let's do it again. Cancel by 4. Make another 9. I've got a 9 and a 9 and a 4. They don't cancel. They don't cancel. So now I've got 10 plus 81 over 4. You know how I should write 10 over 1? Let's multiply by 4. 40 over 4. So 121 over 4. And that's going to be feet. At what time does it hit the ground? Oh, this is the test question that a lot of people got wrong. Should we do H or K? And the answer is neither. Oh, the ground is right here. That's not H or K. Okay. No, you must be a physics person. I know a lot of times in physics, you guys just take regular parabolas, you take the H value, and then you times by 2. But this isn't a perfectly, that would take you to here. So when it doesn't start at 0, no, you can't just double that time. If it started at 0, yes, you could use that trick. But we're going to have to put 0 in for the y value. And then we're going to have to go ahead and see if we can factor. Can you take a number out to make the factoring easier? Negative 2? Take out negative 2. That gives us 8t squared minus 18t minus 5. Okay, so let's just walk through the MA table here, because a lot of people, yeah, they know 20 and 2. So you've got negative 40, negative 18, and you've got 20 and 2 with the negative on the 20. So is it t minus 20 and t plus 2? No, what do you do with these numbers? You got to split the middle. Okay, don't jump to the end. So we've got 8t squared minus 20t plus 2t minus 5. All right, now we'll do some factor by grouping. Some people just like to go ahead and check with, like guess and check with their factoring. I will take out, how about a 4t? Take out 4t, giving us 2t minus 5. Down here, I'll take out plus 1, giving us 2t minus 5. So for people that liked the guess and check method, you probably would have came up with 4t plus 1 and 2t minus 5. So there's two t values. T is negative 1/4, or t is positive 5/2. So why am I getting two answers here? Yeah, one's negative. So if you go back in time, this parabola would have hit here at negative 1/4 time. But this is the right answer, 5/2 seconds. So don't forget, when it says hit the ground, that is put 0 in for y. That's an x-intercept. Okay. So the second half of the chapter dealt with borders, rectangles, money, projectile motion. You hated the money? The money? Okay, so let's take a look at this one here. We're going to build a rectangular area up against the side of a barn. Do you remember what that meant? There's what? Yeah, there's only going to be 3 sides. Oh, this black pen doesn't really work anymore. So I'm going to take a stick that says 200 feet of fencing and chop off how much for the left? Chop off X, put it on the left. Chop off X, put it on the right. Okay, how many more sides are left? Just 1. Sometimes there's top and bottom, but here there's only 1. So let's take the entire piece of fence that's left, which is 200 minus 2x. I don't need to cut that in half. I'm going to put that exactly on the bottom there of that rectangle. Okay? If it did have top and bottom, then it would be 100 minus x. All right, area, A of x. Base times height of a rectangle, x times 200 minus 2x. Should I distribute? Why? Yeah, because you have to, because we need to make well, this is a parabola. But how are you going to do H and K formulas without an ABC? Right? Okay, so I'm taking a look at a little diagram just to kind of get the juices flowing. If it doesn't say draw a diagram, I suggest a quick little sketch because then you know what to go for. I've got X, I've got A of X. X represents the width, A of X represents area. It says, what is the maximum area? So if you take a look at this parabola, maximum area, should I go for H or K? K, all right? Even if it doesn't say draw a diagram, that's how we did it in class. Do it the way you're used to, and then your brain will have memory sparks. It'll go back to the way that you learned it, and then you'll know what to do. Give me a C. 0 minus B squared. 200, 200, all over 4, negative 2. Don't multiply those big numbers. Let's cancel. Cancel negatives. Let's make a 100 here. And let's not mess him up. Let's leave 100. 4 goes into 20, 50 times. All right, I've got 5 times 1 with how many more zeros? 3 more zeros. How about some units? Feet squared. Okay, maximum area. All right, so there's 2 types. We talked about both of them there. Money problems. Okay, make sure this is on your note card here a little bit. So the idea with the money problems is there's cost times number of things. And as one goes up, the other one goes down. Okay, so let's read the problem first just to get an idea. The candy bars are selling for 80 cents. It's pretty cheap. There's 1,000 sales per week. The study reveals if you increase the price for every increase, that's the magic word, for every increase, so X is going to be number of increases. Okay. Oh, there's 20 less people that can afford to buy the candy bar. So do you know the cost? And do you know the number? Okay, let's get started here. The current cost is 80 cents. Is that going up or down? Okay, how much is it going up? Is it just going up 10 cents? Oh, 10 cents. X. Maybe I increase it 2 times. Make it $1. All right, how many sales are there? 1,000 candy bars being sold, and that's going to be going down. Just 20 less people? Well, 20 to X. Every time I increase, I lose 20, I lose 20, I lose 20. Let's go ahead and multiply this out. If you multiply by 1,000, take the decimal and move it how many places? 3 zeros, 3 places. 1, 2, that's 800. Okay, outers. Negative 16x. How about the inners? Plus 100x. And lasts are going to be negative 2x squared. Okay, so let's go ahead and clean this up. We've got negative 2x squared plus 100 minus 16 is? Mark? 84x plus 800. Good. All right, let's draw the graph just to kind of get an idea of what's going on here. So I've got x, which I already said was number of increases, and r of x is total money. Total money. This is the cost times all the sales, total money. How many times should the price be increased? Kyle, should I do H or K? H. Negative B over 2A. Negatives cancel. If you don't know 84 divided by 4, let's just cancel by 2. That's 42 over 2. So that's 21 increases. 21 increases. Wow, I really want to charge a lot for these candy bars. What's the new cost of the candy bar going to be? So if I take a look at cost right here, some people like the equation. Some people just like to do the thinking method. I know it's 80 cents, and I'm going to take that dime and increase it 21 times. So 80 cents plus 2.1. Yeah, right? Okay, isn't 0.10 like 10%, people? Isn't it like 10%? And when you go to the store, they say take 10% off. Don't you just move the decimal over one time? Okay. $2.90. Who would buy the candy if it was $2.90? All the rich people.